This video is on determining if a triangle is right-angled, and I want you to think about the question we did in class today where there was a triangle but it had no little box inside, that little box that tells us that there is a 90-degree angle in the triangle or that the triangle is right-angled, and everybody happily applied Pythagoras' theorem to this triangle, but we didn't know for sure whether it was a right-angled triangle. Well, firstly, Pythagoras' theorem can only be applied to right-angled triangles, and so if the triangle is not right-angled, then you really shouldn't be applying Pythagoras' theorem. Secondly, just because a triangle looks right-angled doesn't mean it is. So that little box, if it's not there, maybe that angle's 89 degrees, maybe it's 91 degrees. We wouldn't be able to tell this with our own eyes, with our naked eye. So you really need another way of determining if a triangle is right-angled. So what we can do is use our knowledge of Pythagoras' theorem. We now know that Pythagoras' theorem can be applied only to right-angled triangles, and so therefore if a triangle is right-angled, then Pythagoras' theorem should hold true for that triangle. So here's the kind of example I'm talking about, where you have a triangle, and we can see that in this triangle, if there was a right angle, it looks like it would be here, okay, and opposite the right angle would be what we call the hypotenuse. But we don't have a right angle over here. We've got to determine if that is a right angle. So for these kinds of questions, we're not actually finding sides, we're determining if the triangle is right angled. So if this triangle is right angled, then Pythagoras' theorem holds true. We know, or should hold true, we know that Pythagoras' theorem is c squared equals a squared plus b squared. So all we have to do is check, if I square the hypotenuse, will it be equal to the sum of the squares of the two shorter sides? So here are my shorter sides over here, and all I have to do is check that. So for these kinds of questions, it's very important that you set your work out a certain way, and I expect your work to match the kind of setting out that I'm about to show you. So what we're going to do is look at the left-hand side of Pythagoras' theorem. Here I've written Pythagoras' theorem out for you, but this is the left-hand side of Pythagoras' theorem, and on the other side of the equal sign is what we call the right-hand side. And we're going to check both sides of the Pythagoras' theorem and check if they're equal. Because we know that if Pythagoras' theorem does hold true, then c squared should be equal to a squared plus b squared. So let's look at our sides of our triangle, and we can see that if this is a right angle triangle, well, the longest side we can call C, and the two shorter sides, doesn't matter which one's which, we'll call them A and B. And we're going to look at the left-hand side of Pythagoras' theorem, and we're going to look at the right-hand side. Well, the left-hand side of Pythagoras' theorem is C squared. And if I take my C and I square it, you can use a calculator for something like this, I'll get 196. Now, if I look at the right-hand side of Pythagoras' theorem, that's a squared plus b squared. I can take the a, which is 11, and square it, and the b, which is 6, and square it. That's going to give me 121 plus 36, and if I add that together, I'm going to get 157. And now I need to think about what I can see. The left-hand side produces 196 when I square the hypotenuse. The right-hand side produces 157 when I sum the squares of the two shorter sides. If Pythagoras' theorem were to be true, then the c squared should be equal to the a squared plus b squared. Are they equal? Clearly they're not, okay? So at this point, I'd be writing down, or telling my examiner that the left-hand side doesn't equal the right-hand side. Okay, and therefore c squared does not equal a squared plus b squared. And if c squared is not equal to a squared plus b squared, we can conclude the triangle is not right-angled. So bear with me, getting used to this stylus. Triangle is not right-angled. So if c squared was equal to a squared plus b squared, our conclusion would be slightly different. In that case, we would say the triangle is right-angled. So in this case, there is no little box there, and it is not a right-angled triangle. Let's try this again. I'm going to look at one more example. Once again, it looks like a right angle triangle, but that doesn't mean that it is. So if there was to be a hypotenuse, it would be, whoops, get my pen. It would be the longest side, which in this case is 41. And then I've got my two shorter sides here of 9 and 40. So we're going to look at the left-hand side of Pythagoras' theorem, and we're going to look at the right-hand side of Pythagoras' theorem. The left-hand side of Pythagoras' theorem is c squared, and the right-hand side of Pythagoras' theorem is a squared plus b squared. Just to remind you, left-hand side and right-hand side is just the notation for the two sides on either side of an equal sign. This is left of the equal sign, and this is right of the equal sign. So we call this side the left-hand side, and we call this other side the right-hand side. So in this case, c squared is going to be 41 squared, and it's not something I know in my head, so it's perfectly fine to work it out. That's 1,681. Work it out on your calculator. And over here, I'm going to add my a squared plus b squared. Now, it doesn't matter. This can be a and this can be b, or vice versa, whatever suits you. So they're just both the shorter sides. So I'm going to find the sum of the squares of the two shorter sides. So sum, I'm going to add them together. I'm going to square them. So we've got here 9 squared, which is 81, and 40 squared, well, 4 fours are 16. And I'll also need 2 more zeros. And when I add them together, I get 1,681. Well, what we need to do now is have a think. I found my c squared. I found my b squared plus c squared. And it turns out that the left-hand side does equal the right-hand side. It's an important conclusion to make. And then we can say, well, that means I found that c squared equals a squared plus b squared. I know it seems like we're spelling it out, but really we're just being very, very clear. And if c squared equals a squared plus b squared, well, this triangle over here must have a right angle there. It must be a right angle triangle, because Pythagoras' theorem only holds true for right angle triangles. So we can conclude, therefore, the triangle, the triangle is right angled. Okay. I hope this video makes sense. Please feel free to go back to certain slides or pause it to make sure your setting out matches my setting out when you go and complete the examples in your notes, which you are welcome to do. If it's not 100% clear, you might want to rewatch it again, or you can just ask me a question.